In this example, we're looking at CVP analysis, that is contribution margin, and we're going to look at the situation where we want to choose a level of output of, or choose between different products given their contribution margin, and we know that normally we're going to be maximizing contribution margin per unit of the limiting factor. So let's look at this case here where we have different limiting factors in different circumstances. So Joe would like to open a restaurant in which to serve good American food to a discriminating group of customers. Unfortunately, Joe is not a good cook, and in fact his cooking skills are minimal, and the menu will consist of simply two items, one of which is skillet eggs with sausages, and the other is pancakes. And to cook even this restricted menu, he'll need to employ a chef, loosely interpreting that word, at a salary of $400 per week. The skillet eggs dish will have a selling price of $5, and the pancakes will have a selling price of $3. And we're told that the ingredients for the skillet eggs cost $3, and those for the pancakes are $1.50, and rent, utilities and other fixed costs amount to $260 per week. So, assuming that the eggs are twice as popular as pancakes, how many meals a week must he serve to break even? And this is a case where we're doing CVP analysis with multiple products, and one way of looking at that, or the first way of looking at that, is to say, let's consider a fixed ratio of products and look at the number of packages. So in this case, we're told that the eggs are twice as popular as pancakes, and so, if you like, this package of meals, package of 3 meals, would consist of 2 packages of eggs, 2 meals of eggs. It's like 2 customers coming in and order skillet eggs and sausages, and 1 customer comes in and orders pancakes. And so we can say, well, okay, the first meal, eggs, that would have a selling price of $5, and the variable costs associated with that are the ingredients for the skillet eggs, which we're told was $3, and so there's a contribution margin on each eggs meal of $2. And again, in this package, we'll say, okay, the second package is exactly the same. So again, selling price of $5, variable cost of $3, contribution margin of $2. And then there's the pancake meal, which we're told has a selling price of $3, and the variable costs of the pancakes was $1.50. And so the contribution margin coming from a meal of pancakes is $1.50. And so in aggregate, for these 3 meals, or for this package of 3 meals, it's saying that in effect that the selling price of this package is $13, the variable costs associated with the package is $7.50, and the contribution margin is $5.50. In answering the question, how many meals a week must he serve? So we'd say, well, we know that break-even is profit of 0, that's the definition of break-even, and we know that the fixed costs, well, the fixed costs are, let's highlight this, the chef's salary, and that was a salary of $400 per week, and the other costs per week are $260 per week, and so, okay, the fixed costs that have to be covered are $660, and so it must be that the contribution margin on these meals is $660, because if we have a contribution margin of $660 less the fixed cost, that will give us a profit of 0. So we can say, well, how many packages does he have to sell? We know that each package is going to have a selling price of $13. The variable costs of each package we just worked out was $7.50, and so the contribution margin per package, this package of 3 meals, is $5.50, and so the volume of packages, that is the number of packages of meals he needs to sell, is 660 divided by 550, because if we take that answer, 120, then 120 packages with a contribution margin of $5.50 each will give a total contribution margin of 660. We can subtract the fixed cost, 660, and that will give us the break-even of 0 profit. And of course, this 120 packages then, we know actually represents, well, 120 packages is 120 meals of pancakes, and where's the other one? Have we got the other one? Yes, 120 packages and 240 servings of eggs and sausage, 120 of packages, and the total sales revenue is 120 times 120 lots for $13, 1,560. And so the question is, how many meals a week? It doesn't actually ask us the break even in dollars, asks us the break even in meals, and the answer is 360 meals. But as I say, if we want to break it down, it'd be 240 of eggs, 120 of revenues. Or of course we could do it in terms of the average meal, and we know that the weighted average cost per meal is, well, it's the $13 divided by the 3 meals. That's 2 lots of $5 and 1 lot of 3 divided by 3, so $4.33. The average variable cost per meal is $7.50 divided by 3, which is $2.50. And the weighted average contribution per meal then is the $5.50 up here, right? This $5.50. And then divided by 3 meals is $1.83 per meal. And if we worked on that basis, then we would say in terms of individual meals that the average price per meal is $4.33, the variable cost per meal is $2.50, the contribution margin per average meal is at $1.83, break even is a profit of 0, fixed costs we know were 660, and so break even, total contribution at break even must also be 660, and so the volume of average meals is 660 divided by $1.83, again 360. So doesn't matter which way you do it, we can either work in terms of the average meal or we can do it in terms of the package. We'll end up with the same answer, 360 meals. Okay, so now let's look at sort of interpreting or implications of this calculation. So first question, which is the more profitable product? That is, if a customer comes in and asks for advice about the merits of one dish over the other, which should he recommend? Well, assuming that he's going to recommend the one which is most profitable, not, there's nothing to choose between them. There's no reason to think that the customer would enjoy the skillet eggs more than the pancakes or so on. Then what are we looking at? Well, either can sell a meal of, where are we, up here? So either he can sell or recommend and sell skillet eggs and sausages, which has a contribution margin of 2, or he can recommend and sell pancakes. Sure, the revenue's better for the eggs, or higher for the eggs, but then the costs are higher as well. And so what we want to do is maximize contribution margin per unit of the limiting factor. And what's the limiting factor here? It's per meal. And so contribution per meal is either $2 per meal for eggs and sausages, or $1.50 for the pancakes. And so clearly contribution margin per meal, the higher number is going to be the skillet eggs and sausages. And so we can see that here. Contribution margin per meal is either $2 or $1.50. And so choose the one with the higher, sausage and eggs. Okay, part C, or question C. How does our answer change if the customer is a group of 5 poor students who between them have $15 to spend on food? They're prepared to spend it all, and they're going to share the food between them. What do we care about now? Well, we'll go back to contribution margin per unit of the limiting factor. And what's the limiting factor in this case? Well, the limiting factor is the amount of dollars that are going to be spent. And so that's going to be contribution margin per dollar of revenue. And so if we look at the spent on eggs, then the contribution that will be earned is, well, it's $15. And we know that the contribution margin on the skillet eggs and sausages meal is 40%, because out of the $5 selling price, then the contribution margin is $2. That is 2/5, 40%. Or if you like, you could say, well, $15 would enable the students to buy 3 orders of eggs and sausages, and they'd share it between them. And those 3 orders would generate a contribution margin of 3 lots of $2. That is $6. So the total contribution margin would be $15 times 4, which is, and I haven't done that yet, let's put it in, is $6. Whereas if Joe were to recommend that they bought pancakes, then sure, they could get more orders because it would be $15 divided by, and the selling price is $3 per order of pancakes. And so in that case, contribution margin would be 50% of the $15. It would be 5 orders of pancakes at $3 each. And we know that each order of pancakes, up here we can see each order of pancakes generates a contribution margin of $1.50. And so $1.50 per $3, or 50%. And so in terms of recommending, or in terms of what we choose when we want to maximize contribution margin per unit of the limiting factor, and the limiting factor is sales revenue, we're going to use the contribution margin ratio. Okay, so 40% for eggs, 50% for pancakes. We'd recommend the pancakes. Okay, question D. How does your answer to B change? So which is a more profitable product? How does the answer to B change if the restaurant becomes very busy over lunchtimes and the number of customers that can be served is restricted because the chef does not have time to cook all the dishes, and the skillet eggs take 3 minutes and the pancakes take 2 minutes? So in this case, we're going to be saying, okay, let's look at the contribution margin per unit of the limiting factor. And now the limiting factor is cooking time. So we can say, well, with eggs, we get this contribution margin of, and what was it? Contribution of eggs was $2. So $2 spent on 3 minutes. And so $2 on 3 minutes is 67 cents per minute. The pancakes only generate a contribution margin of $1.50 and take 2 minutes. And so in this case, we can see that contribution margin per unit of the limiting factor is 67 cents per minute, and the pancakes are again a better deal because although it's a lower contribution margin, it's also a lower cooking time, and in proportion, the pancakes are generating contribution margin at 75 cents a minute, sausages and eggs 67 cents a minute. So we'd go for that. Okay, suppose Joe wishes to maximize contribution earned over a 2-hour lunch period, and we're told that the restaurant can serve 50 diners in that time and the available time to the chef is 120 minutes. Well, now we've got different factors. There's the cooking time of the chef, but there's also the number of, if you like, the turnover, the length of time that the customers will be at the table. So a mixture of things. So what are we going to do? We've now got the two constraints, both the fact that we can't have, or we can't serve more than 50 meals, and we can't have a cooking time of more than 120 minutes. And so we can set this up as what's called a linear programming problem. We're going to say, well, let's have a function. Our objective, what are we trying to do? We're going to maximize 2x plus 1.5y, where, let's put the results in here. We're going to maximize the contribution subject to not exceeding either of the resource constraints. So if we let x is the number of eggs meals that we sell and y is the number of pancakes meals that we sell, and then we can say, okay, we're going to make $2 for every egg meal. That is $2 contribution for every egg meal, $1.50 for every y meal. So the total contribution will be $2 eggs meal multiplied by the number of egg meals, so 2x, and similarly plus 1.5y. And then there are going to be constraints. The constraints are that the number of meals that we serve must be no more than the seats available. So the number of meals in aggregate must be less than 50, if you like, less than or equal to 50, but it's difficult to get the less than or equal sign there, if you like. Maybe I could just try underlining it. It doesn't look quite the same, but it'll do. Let's do that. There you go. Less than or equal to 50. And the other constraint, or another constraint, is that the time for the chef to cook the meals must be less than 120. So we know that the total cooking time is 3 minutes for every egg and 2 minutes for every pancake. So 3 times the number of egg meals plus 2 minutes times the number of y meals. It's got to be less than 120. And we also have constraints that we have to have non-negative number of meals. You can't have negative meals, though in fact in this case that wouldn't be an issue. And so we can set this problem up in Excel, and overall then we'd have our objective function maximized 2x plus 1.5y subject to the constraints x plus y is less than or equal to 50, 3x plus 2y is less than or equal to 120, and then the standard non-negativity constraints. And as I say, we can do that in Excel and use Solver, but I'm not going to do that now. You'll deal with that in a different course.